we discuss Rufus and how it works. Rufus is a lightweight Windows utility that creates bootable USB drives by detecting a removable device, wiping or reconfiguring its partition table, creating one or more partitions with a chosen partition scheme MBR or GPT, and file system, FAT32, NTFS, exFAT, and then copying installation files from an image or performing a raw image write. This process results in a USB drive that a PC firmware BIOS or UEFI or bootloader can start from. It uses low-level access to format and configure the drive, requiring administrative privileges to operate. When preparing a drive, Rufus enumerates and locks the target device, unmounts any mounted volumes, optionally runs bad block checks, and writes a new partition table based on the user's selected options. For UEFI targets, it creates an EFI system partition and places EFI boot files there. For BIOS legacy systems, it writes MBR boot code and the necessary bootloader files. Rufus supports two main write modes, ISO image mode and DD mode. ISO image mode extracts files from the ISO and arranges them on the USB with the correct bootloader, making the drive usable both for installation and file storage. DD mode writes the image sector by sector, producing an exact clone of the source, which is necessary for certain hybrid ISOs or specialized disk images. Rufus can detect ISO hybrid formats and prompt the user to choose the best mode. Some UEFI firmwares require FAT32 for booting, but FAT32 cannot store single files larger than 4 GB. To work around this, Rufus can use a UEFI NTFS bootloader that starts from a small FAT32 partition and then loads the operating system from an NTFS partition containing the larger files. Alternatively, large files can be split into smaller parts or placed on a separate NTFS volume alongside the FAT32 boot partition. When creating Windows installation media, Rufus arranges files to meet UEFI and BIOS requirements and can split large WIM files if needed. For Windows to Go setups, it installs Windows so it can run directly from the USB drive, though performance and hardware compatibility vary. Internally, Rufus detects the image's structure, identifies the correct bootloader such as syslinux, grub, or EFI loaders, and executes either file extraction or raw writing depending on the chosen mode. Advanced options allow for persistent storage on some Linux distributions, bad block scanning, and command line automation. Best practices include using ISO mode for most operating systems, DD mode when exact raw copies are needed, selecting GPT, UEFI, or MBR BIOS according to the target system, and backing up any important data on the USB before running Rufus, as all existing data will be erased.